This is 8th grade math, and today we're going to be talking about slope. Slope you'll hear a lot about when we study equations. Take good notes today, please. Pause the video, go back, check these over. Slope, in 7th grade you might have heard of it called the rate of change, or the unit rate, or sometimes the constant of proportionality, depending on which lesson you went through. Slope is found, it is the rise over the run, which means it's how far up or down a line goes, divided by how far side to side. Remember, rise is our rise is our y values, run is our x values. So we can think of this as our y's, and this one is our x's. Okay, a positive slope looks like this. It moves up in a positive direction. It should be pointing up and to the right. A negative slope is going to be pointing down and to the right, or up and to the left, depending on how you read it. So positive slope looks like this. Negative slope looks like that. The closer a line is to being straight up and down, the larger the slope is going to be. So here's a positive slope, and see how the line is very close to being straight up and down? That might be like a positive 5. The closer it is to the horizontal line, the closer it is to the x, to being straight across, the smaller the number is going to be. This might be like positive a half here. Same thing with negatives. The closer the negative line is to straight up and down, the larger it's going to be. Excuse me, the larger the number will look. So maybe like this is a negative 5. The closer it is to being horizontal, this might be like a negative a half. Remember, this only works for functions. Functions need to pass the vertical line test, which means for any function, these are all linear functions, but there are other types, you have to be able to draw a vertical line, and it has to be able to touch only one point, no matter where you put that vertical line. So, if I took a vertical line, and I put it right here, it would touch just one point. But if I put it anywhere else on this side of the graph, it's going to touch 2 points. So is this graph a function? No. Nope, it's not. What about this crazy looking thing? If I draw a line, a vertical line, anywhere, it only touches 1 point. So is this graph a function? Yes, it is. It passes our vertical line test. Okay, so let's talk about ways to find slope. A couple of ways we're going to learn about. First way, remember it's rise over run, so our x's over our y's. If you have a chart, or just even 2 points where you have x's and y's, take the second y minus the first y, and then the second x minus the first x. Let's look at what that looks like. Here is a chart with x's and y's for a function. X's, y's. Pick any one other than the first value to be your second value. Doesn't matter which one you choose. I'm going to choose that one. 3, 9. So my y2 is going to be 9. And my x2 is going to be 3. Now I'm going to subtract from that an x and y that come before it. That's why you can't pick the first point the first time, because you have to pick one before it for the second number. I can pick either of these. I'll pick the next one, because that looks fine. I'll do this one next. 2 and 6. 6 is my y. It's going to be my earlier coming y. That makes it my y1 minus 6. It's y2 minus y1. y2 minus y1. Now I want to do x2 minus x1. x2 minus x1. Well, let's see here. Now we can solve. 9 minus 6 is 3. 3 minus 2 is 1. 3 divided by 1 is 3. The slope for this particular input-output chart for this function would be 3. If I just had 2 points, I could do the same thing. Even if I didn't have all of the points, I could do it here. Remember, our first number is always x and y. X and y. Which one do you think is our second one? The ones in the second parentheses. So here's y2, here's y1, here's x2, here's x1. y2 minus y1 would be negative 1 over 0. Negative 1 minus 0. And then x2 minus x1, 5 minus 0. x2 minus x1, 5 minus 0. This is the formula to calculate slope. y2 minus y1 is x2 over x2 minus x1. Negative 1 take away 0 is just negative 1. 5 minus 0 is 5. Negative 1/5. I can leave it as a fraction. Even if it was an improper fraction, I can leave it as an improper fraction. I would reduce it if I needed to. Last but not least, there's another method. If you have a graph, you can make a triangle and count. So here's a graph. Here's my line. Here's 2 points on the line. Now, I could pick any 2 points. I could pick these 2 points if I wanted to. But I'm going to start with these 2 because they're on the lines and they're easiest to count. Now, I'm going to draw lines coming out of both of those 2 points until I have a triangle. See my triangle? Here's my triangle. Now, slope is rise over run. How far does it rise from the bottom of the triangle? It rises 1, 2. That's my rise. My run is my x. How far does it move? It moves 1, 2, but it moves in a negative direction. Do you see how it's a negative here? Do I count that as negative or do I count that as positive? In this case, I'm not going to count backwards, I'm going to count forward. So count over this way. 1, 2, 2. My slope is 1. I also know that I have to count forwards and not backwards because this is a positive slope. Remember, we learned that this is what a positive slope looks like. If I tried to count backwards, I would end up with a negative number. Now, I could have picked these 2 points, and I could have drawn a triangle here, and I would have gotten the same answer. It is 1, 2 up, and 1, 2 over. 2 over 2 is 1. If it was truly a negative slope, I would see that my line was negative, and I would know to put in my negative numbers to help me calculate my slope.